Children, in this session we will learn how to score 100% marks in physical sciences. Okay, so one lab activity can bring 8 marks, both from reflection of light at curved surfaces and refraction of light at curved surfaces. So before going to face the examinations, you have to keep 4 things in your mind. What are they means? First, they will ask the questions from conceptual understanding, Second one is activity based. The third one is information skills. And the fourth one is diagrams. See, in diagrams also, first 4 lessons are very, very important. 1 to 4 lessons. Remember that. First 4 lessons. The fifth one is uses and daily life applications. Okay, in this session we will cover activity based questions from reflection of light at curved surfaces and refraction of light at curved surfaces. Okay, are you clear about that one? Activity questions, activity based. One is the reflection of light at curved surfaces, the other one is the refraction of light at curved surfaces. Are you clear about that one? So it brings 8 marks. Okay, before last year they have given only for 4 marks. Whoever they prepare the question paper, whether SCRT or private or government, whatever they may be, whoever they prepare the question paper, this is the way they have to ask the questions. They have to give the questions from conceptual understanding, and they have to give the questions from activity based, they have to give the questions from information skills. These are the categories. They have to give the questions from diagrams, and they have to give the questions uses and daily life applications. Are you clear? These are the 5 categories they divided while preparing the question paper. Are you clear? So in this session we will discuss activity based questions from the first lesson, that is reflection of light at curved surfaces and refraction of light at curved surfaces. Okay, you make a note of this first of all. This question is given in the annual examination in previous papers. Okay, you will find several times this question. Okay, and a table is given, and you are asked to write the nature of the images and to find the focal length also. Sometimes they will ask. Okay, so what is the question? List the materials required for conducting an experiment to find the focal length of concave mirror. Explain the experimental procedure. Not only concave mirror, they may ask convex lens also. Whether from refraction, they may ask the question, same procedure. Okay, whether from refraction and reflection, process is same. But here whenever you are asked about reflection means you have to write concave mirror. Okay, there in the case of refraction means you have to mention convex lens. Do you understand? All other materials are same. So whenever this type of question is given, experimental based question is given, these are the steps you have to remember. What are the steps? First, aim. What is the aim of that experiment? Here in this experiment, what is the aim? To find the focal length of the concave mirror or given lens. Okay, first what is the aim you have to write? To find the focal length of concave mirror oblique lens, that is double convex lens. In the textbook it is given double convex. Okay. So whenever this type of question is given, first you write the aim. What is the aim of the experiment? After that, what are the materials required? Simple thing you have to remember. The materials required. See this one. First a meter scale. Okay, a meter scale. Next one, concave mirror. Concave mirror. If in the case of lens, double convex lens. Okay, double convex lens. The next one is V stand. What is that? V stand. So what are the materials? Order is not important. So what are the materials needed? One is the concave mirror. One is the concave mirror. The second one is the meter scale. What is that? Meter scale. Next one, V stand. V stand. Next one, optical bench. Optical bench. Next one, to catch the image, you need a white paper which serves as the screen. It serves as the screen, white paper or screen. These are the materials needed. These are the materials needed. We are doing distance object method. Two methods are there. One is the distance object method. Another one is the, what is that? Object distance, by measuring object distance and image distance using the candle. Using the candle. Are you clear? Two methods are there. In any manner you can find it. Are you clear? So process is same. Process is same. In the case of distance object method, I am doing to find the focal length of the mirror, concave mirror, using distance object method. Distance object method. So what are the materials needed? First one is the concave mirror. Second one is the meter scale. Third one is the V stand. Next, fourth one is the screen, white paper. Fifth one is the, all are covered, concave mirror, meter scale, V stand, screen and optical bench or bench, whatever it may be. Optical bench. Okay, next one, here you remember, see we are doing distance object method. If you use the candle, you have to write candle also. In the case of refraction, you have to write, what is that? Double convex lens, here you have to write. These are the materials common in both the cases. In the case of reflection and in the case of refraction, okay, to find the focal length of the lens or mirror. Okay, next one, what is the procedure? What is the procedure? Means procedure in the sense how you are doing the activity. How you are doing the activity. So see, procedure, remember that first arrange the bench in the middle of the class. In the middle of the class. Next one, keep the V stand. Keep the V stand. Next, keep the mirror. What is that? Concave mirror. This is the concave mirror. Okay. Keep the concave mirror on the V stand. Are you clear about that one? Next one, take a white paper. Take a white paper. It serves as the screen. It serves as the screen. Focus the mirror towards the distance object. Towards the distance object. Okay. What is the distance object there? I have chosen the tree. I have chosen the tree. See this one. See this. Can you find the image? See this. You close the window. Can you see the image? Can you see the image of the tree? You find the inverted image. Observe this carefully. You find the inverted image of the tree. Okay. Which is far away. Okay, you stand up and observe. Can you see it? You have to adjust the position of the screen so that you can catch the clear and sharp image. You come and observe. Okay, you come. Can you see the image? You come. here. Okay, can you see the image? Okay, inverted image of the tree is formed. Okay, so what you are doing, you are adjusting the position of the screen so that you can catch the clear and sharp image. Sharp image, manchi image, spastanga kanapade image వచ్చేంత వరకు మనం ఏం చేస్తున్నాము, we are adjusting the screen. If it is here, it is the sharp image. Observe this one, now it is sharp. Okay, now it is sharp. The image is very sharp. Okay, so now observe the distance between the pole of the mirror and the screen. One come. Observe the distance between the pole. You keep like this. This is 1 centimeter. One thing. Okay, right. This is the pole of the mirror, right. See this. Observe this. It is nearly how much? 20 centimeters. Observe this one. It is nearly how many? 20 centimeters. Okay, so the distance between the pole of the mirror and the screen is how much? 20 centimeters. So the focal length of the mirror is how much? 20 centimeters. Are you clear? It is 20 centimeters. Are you clear? Next, process is same. In the case of the lens, this is the lens. This is the lens. See, I am pointing the distance object. See, we are doing the experiment simultaneously. One time we are using the spherical mirror, that is concave mirror. Another time we are using the convex lens, double convex lens. Now observe this one. See this. Observe this. Come this side. Can you see the image of the tree? Is it sharp? Here now? Now it is sharp. Okay? Now it is sharp. See this one. Okay? So you have to adjust the position of the screen so that you can catch the sharp image on the screen. Now measure the distance between the pole and the screen. I am observing this one. See this one. It is 15 centimeters. Observe this one. This is 15 centimeters. How much? 15 centimeters. So the focal length of this double convex lens is equal to how much? 15 centimeters. Are you clear about that? This method is known as what we call it? Distance object method. What we call it? Distance object method. Okay. See, already we discussed the procedure. Okay. What is the procedure we followed here? I have arranged the optical bench and I kept the V stand. There I erected the mirror, concave mirror. If it is in the case of lens, double convex lens, whatever the lens may be. Next one, after that I focused the mirror towards the distance object, mirror or lens towards the distance object, and I arranged the screen, white paper. Okay, I arranged the position of the screen. I moved the position of the screen so that I caught the clear and sharp image. After that, I measured the distance between the V stand and the screen. Okay, practically its value is equal to how much? In the case of the mirror, it is 20 centimeters. In the case of the lens, it is equal to 15 centimeters. Okay, for mirrors and lenses, same. Next one, procedure is same. Next, come to the precautions. These three precautions are very, very important for lenses and mirrors. It is not given in your textbook. See this one. What are the precautions? Move the screen back and forth until the image on the screen is sharp and clear. Okay? Instead of writing this lengthy sentence, inta pedda vakyam rase mundu, meer em cheyali? Shorten it. What you have to do? Adjust the screen to catch the clear image or sharp image. Okay na? Adjust the screen or paper to get the sharp image. Okay? Don't feel that the sentences are lengthy. Concept is very important. Next, come to that one. Next one, after that, measure the distances always from the pole of the mirror, that is V stand and the screen. V stand and the screen. Okay? Next one, avoid parallax error. The third one is avoid parallax error while taking the readings. Are you clear? This is known as distance object method to find the focal length. Okay, are you clear? Right, stop.